Hello and welcome. In this webinar, we want to share the experience we gained with our open source edge computing framework. The webinar will cover the following topics. First, I will introduce the market potential of edge computing and explain the paradigm shift from cloud to edge computing. Afterwards, I will present our vision and the features of our implemented framework. Next, Thorsten will explain our architecture and will present the main components we used. In the final part, I will introduce the success story of Neumann Aluminium, a key partner in development. Here you can see the market potential of edge computing in Europe. Until 2030, the market is expected to grow by 26% every year. As a manufacturer, you want to be part of the coming concept shift in order to profit from the new opportunities it will provide. Two concepts can be seen in this picture, the centralized one at the top and the decentralized one with its variation underneath. At the top, we can see the past trend of the last decade to locate all services in the cloud. This has some drawbacks such as latency or that you are dependent on a fast and reliable network connection. A new approach is that the services from the cloud are shifted closer to the machine and are deployed in an edge device on-premise. There are different variants for an edge architecture. They vary by the amount of edge devices deployed on-premise depending on the required resources. For example, you can have one edge node communicating directly with the cloud, or you might want to have intermediate servers deployed at the premise as well. Our flexible framework is designed to handle all such cases. Our vision together with our partner Neumann was to develop the whole framework based on open source technology. After identifying suitable technology candidates, we evaluated if these technologies satisfy our requirements to be scalable and independent and offline capable. In the final step, we want to develop a smart edge device based on a knowledge graph to semi-automatically adapt data flows based on the captured domain knowledge. Based on the experience we gained while developing the framework with Neumann, the following key features were identified as crucial for the industrial context. We are fault tolerant, and application failure does not cause a production stop. We are also having self-healing capabilities. So after a reboot or hardware change, production will continue with the previously saved state. We support offline operation, so a network failure to a centralized MES would not cause production to interrupt. We are also platform independent and support continuous integration and continuous deployment of applications. We use event-based communication models based on the Redox data flow, and the whole concept is scalable with respect of the size of the production facility. Now I will hand over to my colleague Thorsten, who will explain the architecture of our solution.
Thank you, and also hello from my side to this webinar. Here we can see the high-level architecture of our framework. On the left side, you can see that there are three stages: the shop floor, the premise, and the cloud. In the cloud, we have three different services running. The GitLab server is used to store code and for continuous integration and continuous deployment. In the middle, you can see the Ansible server. The Ansible server is used to remotely deploy applications to different hosts, in our case, the edge nodes. On the right side, you can see an app server. The app server is running Kubernetes. In the Kubernetes, you can run whichever app you like. In our case, it was a Kafka broker, but it might be, in your case, something different. In the middle, you can see the edge nodes. The edge nodes are already basically on premises and really close to the shop floor and the machine. Each edge node can have different applications running depending on the needs of the machine, but at least one application, which is FLETCH. FLETCH acts as transaction manager. FLETCH can communicate with various different protocols from the shop floor, like OPC UA or Modbus or an HTTP request, depending on your needs, and can actually forward it to the cloud, like to the Amazon Web Service cloud or to the Azure cloud, whatever you need, or to the broker, as I mentioned before. It's also capable of making the communication between the edge nodes. So if you want to forward some data from one machine to the other machine, you can do that over the edge node because FLETCH can just send it to the other FLETCH instance. Now we will look a little bit further into the different technologies. First of all, about Kubernetes. What is Kubernetes? Kubernetes is an open source software framework to manage container-based applications. You may have in your company like 100 or 1000 different kind of container-based applications, and if you want to manage them with Docker, it gets really messy. Kubernetes helps you with that. Kubernetes has an administration dashboard to actually administer all the different applications of your needs. Kubernetes offers high availability. So Kubernetes can actually make your applications with zero downtime because it offers a feature with replica sets which actually substitute the application as soon as it's breaking down. It's also scalable. So it doesn't matter if you have 1 node or 10 nodes included, it scales the resources as they are needed. It also supports disaster recovery. Disaster recovery is really crucial when an application breaks down. So you can back it up, this data, and later restore the application to its previous state. A basic Kubernetes architecture can be seen on the slide. It consists of a master node and at least one worker node or multiple worker nodes. The worker nodes are in charge of running the applications. So all the applications you deploy run on the worker node. The worker node is connected with the master node via a kubelet. The kubelet basically sends the communication data to the master node. The master node has different services running to actually store this data and visualize it for an administrator. So you may want to use the CLI commands with kubectl, or you can use the Kubernetes dashboard to actually access all the resources and manage them. Here we have a short video about Kubernetes. Here you can see how I execute a CLI command to actually access the resources in the Kubernetes cluster. I'm getting all the pods. A pod is a containerized application. And you can see that I'm getting all the pod names back and their status. So if it's running or if it's blocked or if it's anything wrong with the pod, I can see this with the command. In the background, you can see the Kubernetes dashboard UI. So if you're not really comfortable with the CLI, you can use the UI of the Kubernetes dashboard provides and administer all the resources of your choice. The next is Ansible. Ansible is also an open source tool to automate IT tasks. So what kind of IT tasks can it automate? It is used to actually configure remote servers or update application on multiple servers. The big advantage of Ansible is that it allows you to define templates in the form of a YAML. In this YAML, you can actually define all the different commands you want to execute on different hosts or on different operating systems. And all these YAML files can actually execute it locally from your machine. So you can basically execute one YAML file on 10 different servers without even SSH into them, and actually just make one mouse click and you have 10 servers deployed. Another nice tool from Ansible is that it's agentless. So you don't need to pre-install anything on the host machine you want to deploy something on. Ansible just connects to the machine and runs the YAML configuration you provided it with. Another nice tool is also that you can combine Ansible with Pixie. Pixie is a tool to remotely deploy operating systems on hardware. So if you combine both, you don't even need to physically touch an edge node if it's somewhere remotely deployed to actually install your whole application set. It can all be done with the Pixie and Ansible together. Now we can see the short video about an Ansible instance where you can see that you can monitor the activities. You have a history log of all the jobs which were executed with this Ansible instance, and you can actually access the templates. The templates are a tool to tell Ansible which YAML files or which configurations files should be deployed on which host. So if you launch basically one of the templates, it uses this YAML file and deploys what's in this YAML file on the host you specified. As you can see here in the video, it's running through the tasks. Last but not least, we have FLETCH. FLETCH I already mentioned before in the architecture, and FLETCH is the transaction manager in our architecture. It's an application to actually gather data from southbound services. Southbound, I mean like from a shop floor, because it supports different protocols like OPC UA, Modbus, REST, MQTT, whatever is your choice, and can actually send it forward to the cloud. In the cloud, it can be Google Cloud, it can be Amazon Web Service, Azure, or a Kafka broker. It can not only forward the data, it can also buffer it. And it can buffer it, and it can even filter it. The filter can be set depending on your needs. There are different implementations of the filter. You can even integrate machine learning algorithms in the filter to actually react to certain events into your machine data. Here we can see a video of a FLETCH instance running. We can see the dashboard where there's no data coming in, and we can see that there are some services deployed or configured in the southbound and northbound to get some data from the shop floor and process it further to the cloud. In this case, it's an OPC UA server plugin. So if you enable it, we actually get data, as you can see here, from the assets. And we can actually send it further north to a REST endpoint. As you can see in the dashboard, we're getting data from south and we're sending it to north. So thank you for your attention. And now Sebastian will tell you about the implementation of our framework at Neumann.
Thank you, Thorsten. Okay, let's take a look at the success story at Neumann. First, a short introduction to what Neumann does. They have multiple production sites worldwide and are a supplier for the automotive industry. The introduced architecture was developed together with Neumann, who turned out to be a great partner for CDP, as they rely on state-of-the-art technology and are experienced with adapting new technologies. In the video we can see the used app deployed with our framework. First we see Node-RED, which is a low-code platform and great tool for debugging and validating small use cases. We also deployed Grafana as a tool to visualize machine data, as can be seen in the video. To centralize the log collection of the edge device, we use Kibana to visualize and store logs from different applications. Currently, the video shows the dashboard of the FLETCH UI, indicating the different south and north data flows. Now we demonstrate how the machine UI triggers the production via FLETCH. So how does this all work together? We can see there are multiple applications deployed in pods to deliver different services. FLETCH handles the machine state and gathers information from the shop floor. In this example, information from a Siemens S7 PLC. Node-RED is used to debug the data stream and as a low-code platform to manipulate the data which is sent to a Kafka server or some server in the cloud. In summary, apart from a few Node-RED flows, a lot of processes can be easily implemented or configured via graphical user interface without having to do a lot of programming. We hope that we have increased your interest in edge computing. Please feel free to contact us if you have further questions. We would be happy if we can support you in setting up a similar edge computing project. Thank you for watching. See you in the next webinar.